All right, geometry students, let's look at Unit 4, Lesson 6, working with trigonometric ratios. So our lesson goal here is I can use cosine, sine, and tangent to find side lengths of right triangles. So cosine, sine, and tangent are the names of the ratios of the sides to each other and how they relate to the angles. So we want to start utilizing those to understand how big an angle is, or how big the ratio is, or the missing sides are. So our vocabulary here is we have our three words, which are cosine, sine, and tangent. We have this triangle that I'm going to reference as I'm talking about how to use these. So cosine is the ratio of the length of the adjacent leg to the length of the hypotenuse, written in the form cos of x, this is the angle, equals b divided by c. So we have our angle x, and the adjacent leg is b here, which is right next to the x degrees. And then we have our hypotenuse c, which is opposite the right angle. So whatever this x is goes in this parentheses next to cosine, and then our b value goes on the top of the fraction, and our c value goes on the bottom, and then this equation would be true. Sine, ratio of the length of the opposite leg to the length of the hypotenuse, written in the way sine or sin of x equals a divided by c. So we have our degrees of x, our opposite side, the leg opposite of x, a there, and c, our hypotenuse, opposite the right angle. So the x goes here next to sine, our a goes on the top, and our c goes on the bottom of the fraction, and then this would be a true statement. Then we have tangent, ratio of the length of the opposite leg to the length of the adjacent leg. So tan of x equals a divided by b. So our x is our degrees here. Our opposite leg is a, straight across from it. Adjacent is right next to the angle. So our x degrees goes here. Our a would go on the top. Our b would go on the bottom. And then that would make a true statement. We're going to learn how to use these ratios and what they tell us. So in this problem, what I want you to do is estimate the value of z. So we have this triangle. We know 40 degrees, 50 degrees, right angle there. We know this side right here is 3, and we're trying to find the hypotenuse, which is z. So I'd like you to use your trigonometric tables to try and estimate how big z would be. And then we're going to use that work to understand how to use our cosine, sine, and tangent ratios that we're going to dive into tomorrow. So bring that to class tomorrow, and that will start our discussion. Thanks.